Hello and welcome everyone. We're happy that we're all together again. In this tutorial, we will start learning about the different kinds of lighting systems which is used in the street lighting. So fasten your belt and let's get started. The aim of this tutorial is to start learning about the different steps of the street lighting systems, so we need to know how to design a complete lighting system for the street with its different parameters. So let's go ahead. First of all, to know how to make a lighting system for any street, we need to recognize the nature of the street itself. So we need to know what are the different components of the street, or what are the different components that the street consists of. And here we say that the street consists of a number of lanes, and the lanes are as separated tracks that the cars are moving through. And those lanes are separated by a guiding line to distinguish between the different lanes on the street. For example, this is a street with two lanes. As you see, we have two tracks that the cars can move through, and they are separated by this yellow guide line which separate the two lanes from each other. And the standard width of each lane of the street to be 4 meters, and this means that if we have a street that consists of two lanes, the total width of this street will be 8 meters, as each lane of them has a width of 4 meters. So the total width will be 4 times 2, which is 8 meters. And by the same way, if we have a street that consists of 3 lanes, here as you see there are 3 lanes separated by 2 guiding lines, and at that case the total width of the street will be 4 meters times 3 lanes, which is 12 meters. So this is a 12 meter street width. So that's for the street width according to its different lanes. Very good. But you know, the street width is an important parameter, as we specify some parameters related to the lighting system or related to the street lighting system according to the street width. So if we specify the street width, we can estimate some parameters related to the lighting system by which we can make our street lighting system. And the first parameter we can specify is the shape of the lighting poles distribution, as the street lighting system is done using some luminaires which are installed on the lighting poles. So those poles have different shapes of distribution, and one shape of them is the single side arrangement. And at that shape of distribution, the lighting poles are installed on one side only of the street. As you see here, we have the luminaires arranged on one side only, while the other side is free or has no poles. And another arrangement type is the double side arrangement, and at that method of distribution the luminaires are arranged in the two sides of the street. So we need to say that according to the street width we specify the shape of the luminaires distribution. And also the second parameter which we specify according to the street width is the pole height, and this is because not all the poles have the same height. So we manufacture the street lighting poles with different heights according to the case we are working on, or according to the street width. Alright. Also, the third thing we specify according to the street width is the number of lanes. As we said before, if we have a street with a total width of 12 meters, it will be divided into 3 lanes, as each lane of them has a width of about 4 meters. So 12 over 4 gives us a number of lanes of 3. Very good. Now we need to know what are the different types of the street lighting systems. As the lighting system of the street has different types or different designs, so we need to know what are those different designs. Here we say that the first type of the street lighting is the single side arrangement, and at that type the lighting poles are arranged on one side only of the street, not the two sides. As you see here, we have the lighting poles are installed on one side only, while the other side is empty, or the opposite side has no poles. But you can ask now, where we use this method, or what is the case at which we use the single side arrangement? Here we say that we use the single side arrangement if the street width is less than 12 meters. So for any street that has a width which is less than 12 meters, we use the single side arrangement. And at that case, we select the lighting pole height to be equal to the street width. So if the street width is 10 meters, for example, we use a lighting pole which has a height of 10 meters also. And we use the lighting pole height to be equal to the street width. This is for the lighting pole to cover all the length of the street, as when the lighting pole height increases, its spreading area of the light will increase. And the opposite is right, as when the lighting pole length decreases, its spreading area of the light will decrease also. So that's for the first type of arrangement. Now the second type of the lighting arrangement is called the double side arrangement or the opposite arrangement. And in that case, the lighting poles are arranged on the two sides of the street. So we have a lighting pole on one side and we have an opposite pole on the other side. And we use this method if the street width equal or larger than 12 meters. So starting from 12 meters of the street width, we use the double side arrangement. And in that case, the lighting pole height equals half of the street width. So if the street width equals 12 meters, for example, the lighting pole height will equal 10 meters only, which is half of the street width. And also, each lighting pole on one side will be opposite to the other pole on the other side. Very good. So that's for the second type of arrangement. Now the third type of arrangement is the double side arrangement. But at that case, the poles are not opposite to each other, but it will have an offset from each other, or it's called the zigzag type, as the luminaires on the two sides make a shape of zigzag. And this means that the luminaires are not in front of each other, but there is an offset distance that the luminaires on one side are opposite to the luminaires on the other side. And we use that method if the street width is larger than or equal 12 meters also. But at that case, the lighting pole height will equal 2/3 of the street width. So we can say that the only difference between the opposite type and the zigzag type is that the lighting pole's height and the opposite type equals half of the street width, while the lighting pole height and the zigzag type equals 2/3 of the street width. Very good. So that's for the difference between the zigzag type and the opposite type. Now the fourth method we have is the median arrangement, and we use that method if there is a median on the street or if there is a straight island in the middle of the street. Like at that case, as you see, each lighting pole has two luminaires installed on one lighting pole. And this is because the lighting pole will be in the middle of the street, so it's needed to illuminate the two sides of the street at the same time. Here one pole is needed to illuminate the street on the right and also the street on the left. So it's needed to illuminate the two sides on the street at the same time. Here one pole will have two luminaires and each luminaire will illuminate one side of the street. The right luminaire will illuminate the right side and the left luminaire will illuminate the left side. And this method of the median arrangement has two cases. The first case if the street width is less than 12 meters, and at that condition the lighting pole height will equal the same width of the street. So if the street width is 10 meters, for example, the lighting pole height will be 10 meters also. And the second case is that if the street width is larger than 12 meters, at that case the lighting distribution will be on the median of the street in addition to the two sides of the street. So we don't distribute only on the median of the street in that case, but we distribute or install the lighting poles on the two sides of the street in addition to the street median. And at that case, the lighting pole height will equal half of the street width. So if the street width is 12 meters, for example, each lighting pole will have a length of 10 meters only. Very good. So that's for the median arrangement with its different cases at which we have a street width larger than 12 meters or we have a street width smaller than 12 meters. But you know, this method of arrangement has some important notes. Here the first note is that in some cases, although we have a median on the street or we have an island, but we don't use the median arrangement. This is because in some cases the median is used for some extensions on the street width. So the width of the median may decrease in the future as we need to increase the street width. So in that case, we will not install the lighting poles on the median as we need the median area in the future and the expansions of the street. And at that case, the poles will be installed on the two sides of the street. And also the second note is that we may have an island in the street, but it doesn't lay exactly in the middle of the street. And this means that the two sides of the street have no equal width. And at that case, the luminaires installed on the lighting pole will be installed on different levels because we have different distances on the street side. And at that case, the luminaires installed on the lighting poles will be installed on different levels. This is because we have different distances of the street width. For example, the right side of the street may have a width of 8 meters, while the left side of the street may have a width of 12 meters. And at that case, the first luminaire will be installed on a level of 8 meters, while the second luminaire will be installed on a level of 12 meters. And this is to cover all the width of the street we have. More than great. So that's about the different types of the street lighting. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. We're happy that we are all together again. In this tutorial we will continue learning about the street lighting systems and its designing steps. So fasten your belt and let's get started. The aim of this tutorial is to continue learning about the different parameters of the street lighting system. Hence, we will know how to set those parameters to the required values according to our designing condition. So let's go ahead. The next factor now we need to take in consideration while designing the street lighting system is the pole distance. And the pole distance is the distance between each pole and the other, or the distance between the pole and the adjacent pole on the same side. So we need to know how to set this pole distance, or what is the factor that we set the pole distance according to. And here we say that the pole distance depends on the type of the street we are working on. This is because not all the streets have the same nature, as there are some fast streets or streets where the cars go through it fastly, and there are some other streets at which the cars moves through it in a slower speed or with a smaller speed limit. And for that reason, the first type of streets we have is the inside city street. And at this type of streets, which lays inside the cities, the car's speed is low, hence the pole distance at this type of streets is about 3 or 4 times the height of the pole. Hence, if the pole height is 8 meters for example, the pole distance may be 24 meters, which is 3 times 8. So between each pole and the other, there will be a distance which ranges from 3 till 4 times the pole height. So that's for the street inside the city. But for streets outside the city, which are the highway streets, at that case the speed of the cars are fast, so the lighting system must be strong enough for the vision to be clear, and this is to avoid any accident in the street. So in that case, the illumination must be larger, and for that reason we make the lighting poles to be much more nearer to each other. So the pole distance at that case will range from 1 till 2 of the street height. So if the lighting pole height is 10 meters for example, the distance between each two poles may be about 20 meters, and this is, as we said, to ensure larger output illumination. Very good. Now we need to know how to calculate the total number of lighting poles and how to calculate the total number of luminaires also. Here we say that this depends on the lighting case we are working on. As if we are working on a single side arrangement, the number of poles will equal the total length of the street over the pole distance plus 1. For example, if we have a sample street that has a total length of 24 meters and the pole distance at that street equals 8 meters, at that case, the total number of poles will equal 24 over 8, which is 3, and we add to it 1, so it's equal finally 4 poles. And for the number of luminaires, it will equal the same number of poles, as this is a single side arrangement where the number of poles is the same number of luminaires. So once we know the total number of poles, we can know the total number of luminaires. Alright. Now suppose we are working on the double side arrangement. In that case, the total number of poles will equal the same total number of poles in the single side arrangement, but at that time we multiply it by 2. So it's equal the total distance over the pole distance plus 1, and all of this term is multiplied by 2. And the multiplication of 2 is to get the total number of poles in the two sides. And also for the number of luminaires, it's equal the same number of poles as each pole has only one luminaire hanging on it. Alright. Now the third case is the case at which we have the median arrangement. And in that case, the total number of poles will equal the total length of the street over the pole distance plus 1. And this is because for the number of poles, it looks like the single side arrangement, as we have only one column of poles at the median of the street. But for the number of luminaires, it's equal 2 times the number of poles, and this is because the lighting pole has 2 luminaires hanging on it. Very good, so that's for the median arrangement. But now we need to know what is the required value of lux that we need to achieve the required street average lux which we are working on. Here, if you remember, in the indoor lighting systems, we said that each type of room needs a specific value of lux according to its type, or our aim was to achieve the required average lux. And here in the street lighting system, we have the same idea, as we need to achieve a specific value of lux which will be suitable to get the required value of illumination. So we say that generally the required value of lux for the street ranges from 10 till 100 lux, and the average value of lux equals the required value of lux plus or minus 10%. So there will be an available tolerance value of 10% as an increase or decrease. But you can say that this range of from 10 till 100 is a large range. So what are the values that we are working on actually? Here we are working on a standard value of lux of 40 lux. This is for the low speed streets or for the streets inside the city. And for the highway streets, we are working on an average lux of 70 lux as a standard value. So those values are given according to the standard codes which we are working on. More than great. So that's about this tutorial at which we discuss some parameters required for the street lighting system, and on the next tutorial we will continue talking about this topic. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. We're happy that we're all together again. In this tutorial we will continue learning about the street lighting systems and its designing steps. So fasten your belt and let's get started. The aim of this tutorial is to continue learning about the different parameters of the street lighting systems. Hence we will know how to set those parameters to the required values according to our designing condition. So let's go ahead. Now we need to focus on the parameters related to the lighting pole itself, as the lighting pole has some parameters which we need to set in a correct manner to produce a correct straight lighting system. And the first parameter related to the lighting pole is the pole height. And the pole height is the length of the pole starting from the ground to the beginning of the pole arm. So this length from the ground to the pole arm is the height of the lighting pole. And this height of the lighting pole has some standard ranges, as the manufacturing companies of the lighting pole are manufacturing the poles with some standard ranges of height. And those values or those ranges are 3, 4, 6 meters, 8 meters, 10 meters, 12 and 16 meters. So those are the standard ranges which we can pick from when we are buying the poles from the market. Also, the second parameter we have is the mounting height of the pole. And the mounting height is the height from the ground to the luminaire itself, not to the arm. So it starts from the ground until the luminaire. And for that reason, the mounting height is larger than the height of the luminaire, as the luminaire has a height level which is larger than the arm level. Very good. Now the next parameter we have is the distance pole to roadway, and this distance pole to roadway as the distance starting from the installation point of the pole on the ground to the starting edge of the street. But you can ask now, why the pole is not installed directly on the starting edge of the street like that case here? Or why there should be an offset distance between the pole and the installation point of the edge of the street? Here we say that this offset distance makes the lighting falling on the street to fall on the starting edge of the street, and this is for the luminaire lighting to cover all the street width. As the arm of the pole has an offset, so this offset of the arm will be cancelled by the distance pole to roadway. And this is to have finally an illumination process starting from the starting edge of the street. But suppose the other case at which we have the pole installation point to start from the starting edge of the street. At that case, the offset of this arm will make the lighting to cover only a distance of the width of the street, while another distance will be uncovered or it will have a lower illumination. So this will be a wrong design at which the distance pole to roadway equals 0. While this design on the right will be a correct design at which the distance pole to roadway equals a considerable distance to cover all the street width. And this distance pole to roadway equals a value ranges from 0.2 meter till 0.5 meter. So in our design, we set the distance pole to roadway with a value that ranges from 20 cm until 50 cm. Alright, now the next factor we have is the arm or the boom. And this arm is that piece that links between the pole and the luminaire, and it ranges from 0.2 till 1 meter. But the important thing now is that it's not recommended to use larger arm lengths, as when the arm length increases, this may make the arm to be broken. As when the arm length increases, it's affected greatly by the external forces like the wind force, so the arm may be broken due to the wind force. So, not to expose the arm to the broken condition, we use shorter arm lengths. Very good. Now the second factor related to the arm or the boom is the boom angle. And the boom angle is the angle that the boom makes with the horizontal axis, which is this angle here. And this boom angle has a standard value or an ideal value that ranges from 15 degrees till 20 degrees. So that's for the ideal boom angle. But this angle can increase to have a maximum value of 45 degrees. So it's not recommended to use a larger boom angle, and this is not to break the arm of the boom. As when the boom angle increases, this makes the arm to be less strong, so it may be broken. And for that reason, we recommend the smaller boom angles of 15 or 20 degrees. As when the boom angle increases, this makes the arm to be less strong, so it may be broken. And for that reason, we recommend to use the smaller boom angles of about 15 or 20 degrees. But at the same time, we should know that when the boom angle increases, this increases the spreading area of the lighting. As you see, when we have smaller boom angle, the lighting of the luminaire is spread on a smaller area. But when increasing the boom angle, the spreading area of the luminaire increases. And when increases it much more, the spreading area is increasing also much more. So we can say that the boom angle has an advantage and a disadvantage. And its advantage is that when it increases, the spreading area increases. And its disadvantage is that when it increases, the boom is exposed to be broken as it becomes less stronger. Alright, now the fifth parameter related to the pole is the overhang. And the overhang is the distance starting from the projection point of the luminaire on the ground to the starting edge of the street. So we have 2 points here. The first one is the starting edge of the street, and the second one is the projection point of the luminaire on the street. And when we link between those 2 points, we get the overhang distance. But this overhang distance has 2 cases. The first one is to be positive overhang, and this is in case of this distance lays on the street itself, as the luminaire projection point lays outside the street width. And the second one is the negative overhang, and this is in case of the overhang distance lays outside the straight width. And at that case, the luminaire projection point will lay outside the straight width also. Very good. Now the next parameter we have is the number of luminaires per pool. And as we said before, we can have one luminaire per pool. This is at that case, for example. Or we can have another case at which we have two luminaires per pool. This is in case of we have a median arrangement. And also we can have more than two luminaires per pool. So there is no standard, but it's according to the case we are working on. So we can have the number of luminaires per pool as what we need. Alright. Also the seventh factor we have is the luminaire IP. As we know, each luminaire has an IP according to its degree of resisting the dust and water. And for the lighting pool luminaire, it's recommended to use a luminaire which has an IP of 67. This is because those straight luminaires are used outdoor, so they are exposed to the external weather conditions of the wind or the dust and the rains, for example. So we need to have a larger IP to against the difficult conditions of the weather. Alright. Also the eighth parameter we have is the lamp type, which is used in the luminaires of the street lighting. So we need to know what is the suitable lamp type which we can use in the street lighting. And for that purpose, we use the sodium lamps. So the sodium lamps are used in the luminaires of the street. And also we can use the LED lamps, as the LED lamps are the most popular type nowadays of the street lighting. And also we can use the metal halide lamps. But for the metal halide lamps, it's less popular in the street lighting due to its larger cost, as the metal halide lamps costs much more. Hence, the metal halide lamps are not the suitable lamp types which we can use in the street lighting, but also we use it in some cases. So that's about the lamp types. But for the metal halide lamps, it's less popular in the street lighting due to its larger cost, as the metal halide lamps costs much more. Hence, the metal halide lamps are not the suitable types which we can use in the street lighting. Very good. After that, the ninth factor we have is the cover of the luminaire which we are using. And for that purpose, we have two types of covers. The first one is the plastic cover, and this plastic cover has some purpose, which is that it's made of the polycarbonate material, and also its second property is that it costs less as it's made of plastic, so it's not expensive, and we can consider its lower cost to be an advantage. But its disadvantage is that it has less light permeability, and this means that it allows lower amount of light to go out of it. So that's for the plastic cover. Now the second type of covers we have is the glass cover. And for the glass cover, it's made of glass and it costs much more. So its disadvantage is that it's more expensive with respect to the plastic cover, but its advantage is that it has a higher light permeability. So the light permeability of the glass is higher than the permeability of the plastic. Very good. Now the last parameter we have is the power of the luminaire. So if we're designing a lighting system for a specific type of street, we need to know how can we select the power of the luminaire which is used in that street. And here we say that the luminaire power depends on the height of the pool which we are working on. As if the pool height is smaller than 8 meters, in that case the luminaire power will be 150 watt, so we will use a luminaire with a power of 150 watt. This is in case of the pool height is less than 8 meters. And in case of the pool height ranges from 8 meters till 12 meters, at that case we will use a luminaire that has a power of 25 watt. And in case of the height has a larger range starting from 12 meters till 16 meters, in that case we will use a luminaire of a power of 400 watt. And in case of the height of the luminaire ranges from 16 meters till 20 meters, in that case we will use a luminaire that has a power of 600 watt. And finally, if the pole height is larger than 20 meters, at that case we will use a lighting pole that has a power of 1000 watts. Very good. So that's for each luminaire power according to the lighting pole height. More than great. So that's about this tutorial, at which we continue discussing some parameters required for the straight lighting system. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. Very happy that we're all together again. In this tutorial we will start practically design the straight lighting system on the Dialux software. So we need to know how to apply on those concepts which we have learned on the previous tutorials during the different designing steps of the straight lighting system. So first of all, we will open the Dialux software. Here we had to double click on this icon, which is the Dialux icon, and then this window pops up to us. So we will select a new straight project as we are working on a straight project. So we select this option by pressing a left click on it. Now you can see this is the initial window that appears for us, which has a default straight example at which we can make or we can apply our design. And here we have the general information about the straight, hence we can change its name, for example, to P, a street inside the city, so we can make it. After that, you can see we have the maintenance plan method tab, so we can access it. Here at that tab, we need to insert the maintenance factor for the luminaires which we have. If you remember, we discussed this concept of the maintenance factor before, as the output illumination of the luminaire decreases due to the surrounding factors, like the dust that accumulates on the luminaire surface or the dirt on the luminaire cover. So all of those factors make some losses on the luminaire surface, and for that reason we take the maintenance factor in consideration. And for the straight lighting, we make the maintenance factor to P 0.7. So let's change it here to P 0.7. And you can notice also it's less than the indoor maintenance factor, because the maintenance factors of the outdoor have a larger effect than the weather factor of the indoor conditions. And after that, we open the third tab, which is the arrangement. And at that tab we enter the number of roadways at our straight, as the straight can have more than one roadway. So if we press on this roadway tab, you can see we have more than one roadway, or we have inserted another roadway. This is because the straight can have more than one roadway, or we can add those two roadways. And also we can add a sidewalk to our straight, as the sidewalk is a smaller way at which the people can walk beside the straight. And also we can add a bicycle lane. This is in case of our straight has a lane for the bicycles to move through it. And also we can add a lay payas, a grass strip, or an emergency lane, and so on. So all of those are some options according to our straight that we are working on. And now we can select all of those options as we don't need them. Here we drag down by pressing a left click and select all of them, and then we press on delete. So by dragging and pressing on delete, we can delete them, and we need only our initial straight here, or our initial roadway that we will work on. And now to enter the data for that straight, we can select it by pressing a left click. You can see those are the information or the designing parameters for that straight which we can enter. First of all, we can change the roadway name to the name that we need. And also we can change the straight width to the width that we need. So suppose that our straight has a width of 12 meters. That's good. And also we can change the number of lanes that our street has. So suppose our street has 3 lanes, not only 2 lanes. It has been changed here, 1 lane and 2 lane and the 3rd lane. And this is considering that the width of each lane is 4 meters. So 4 meters times 3 will give us the width of 12 meters. Alright. Now the next step is to insert the luminaires and the lighting poles which the luminaires will be hanging on. And for that purpose we go to luminaire selection and then Dialux catalog, and then we will select the Philips lighting as we are working on some luminaires from Philips. Very good. Here, this is the Philips datasheet initial window. We can drag it here. And now, as we are working on an outdoor project, as the street is an outdoor project, not an indoor project, so we will select from the outdoor luminaires, not the indoor luminaires. And for that reason, we press on this outdoor selection, not the indoor selection. And also, we can search for the street luminaire according to the luminaire category. So we select here the option of selection or the pace of selection to pick the luminaire category. And here, if we drag this tab down, you can see we have some options to select according to, but we will use this option, which is the road luminaires, as we need the luminaires to be used in the street lighting. So as we are working on a street lighting, we will use the road luminaires. Very good. So those are the luminaires that we are working on, or those are the luminaires that we can select from. And here, if we drag down a little bit, you can see we have the Eco Luminaire category. So the Eco Luminaire category is the economical luminaire, or it's an economical luminaire. And this is a LED luminaire, and it's called economical because this type of luminaires consumes less power, and at the same time, it produces larger output lumens. And here we can select this luminaire, for example, and then we can select this distributor. That's good. You can see this is the luminaire which is hanging on this lighting pole. So this is its physical shape, and those are its datasheet. You can see its total output lumens is 2500 lux, and its light output ratio is 0.9. And its power is 23 watts, so it has a lower input power, and it produces also a lower output lumens. And this is its polar curve. You can see it has a non-symmetrical shape. This is because the distribution of the light on the right side is larger than the distribution of the light on the left side. So that's about an example of the Eco luminaires. Here we can reset all also and go down a little bit. So you can see we have the GRN type, or this GRN is a green luminaire, as GRN is the abbreviation of green. So this is the green category, which is also a LED luminaire. So we can take an example of the green luminaires by selecting this luminaire, for example, and we can select this distributor also, and that's it. And here we can see it has a total output lumens of 11,800 lumens, and also its light output ratio of 0.9, and its power is 123 watt. So it consumes 123 watt, and it produces 11,800 lumens. And this is its shape also, and this is its polar curve. It has the same shape of being unsymmetrical polar curve, as the light on the right side is different from, or a larger distribution than the light or than the rays on the left side. Very good. Now we can see another example by pressing a reset all, and then we can go down a little bit. Here we go down. You can see we have another type of the straight luminaires, which is the sun luminaire. So we can select this sun one, for example, and we can select this distributor, and that's it. This is the sun category, but at that time, this sun category is not a LED luminaire, but it's a pressure sodium luminaire, so it's not a LED one, and it produces a total output lumens of 48,000 lumens, and its light output ratio is 0.81, and its input power, or it consumes 433 watt. So it's very obvious that this type of luminaires consumes a very larger power with respect to the other types or the other LED types that we have discussed, but it produces a larger output lumens. And this is the advantage of the LED luminaires, as they consume lower input power, but here for that type of the pressure sodium luminaires, which has that shape, it consumes larger input power, and you can see its polar curve is more symmetrical, or it has a good polar curve with respect to the LED luminaire polar curve. But you can ask now, from where can we get the datasheet for those street luminaires, or how can we get the variety of the street luminaires which we can select from? Here we answer this question in the next tutorial, at which we will continue our straight lighting design to finish it. So that's about this tutorial. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. We're happy that we are all together again. In this tutorial we will continue designing the straight lighting systems for the street which we have. So let's go ahead. If you remember, in the previous tutorial we ended with exploring some straight lighting luminaires in the Philips catalog. And now we will continue to select the suitable luminaire which we will add to our design. And for that purpose, we will explore the datasheet for some luminaires which we can use in our design. So I have provided for you this file which contains the datasheets for some outdoor luminaires which we can use for any lighting project. So let's access this file. You can see we have those datasheets. We can use some of them in our design. And here for our design, we will access this Speed Star Roads datasheet. So let's open it. Now you can see this is the shape of the Speed Star luminaire. And it's obvious that it's a LED luminaire. And when we go down a little bit, you can see those are the features for this luminaire. And if we go down also, you can see those are the applications or the projects which we can use the Speed Star luminaire at them. Here it's used for the street and for the road lighting. And if we go down a little bit, here you can see those are the specifications of the Speed Star luminaire. And this is its family code. And it has two versions, the medium version and the long version. And the difference between them is that the medium version has a medium length of the light beam, or in other words, its light rays length is medium. While for the long version, it has a long light beam, or its output light rays are long. And also we have another type which is the green line type, and it's a category which has a power range that starts from 27 watt till 180 watt. So there is a variety in the power ranges which enables us to select from them to get the suitable output lumens. And by the same way we have the Eco luminaire which has a power range that starts from 41 watt till 256 watt. Very good. Now what we will do is to pick a luminaire from this datasheet according to its family code, and we will insert this family code in the Philips catalog to get the required luminaire. So let's use this family code which corresponds for the large version. Here we select it, and then we press right click and then copy. Now we go back to the Dialux software, and then we open the Philips catalog, and now we change the selection to be based on the family code. And here we will paste the family code at that part, so we press Ctrl V and then we press enter. Very good. You can see we can select any one of those luminaires, so let's select this luminaire for example, and we can select this distributor A, and that's it. Now this is the shape of the luminaire, and this is its total output flux which is 17,200 lumens, and its light output ratio is 0.81, and for its power is 160 watt. And this is the physical shape of the luminaire, and this is the distribution of its polar curve. Now we will press on add to add this luminaire to our project, and then we close the Philips catalog. And at that point, to insert the luminaire to our straight, we will press a right click and then insert a straight arrangement. And here it asks us if we need to insert this luminaire. So exactly this is the luminaire which we have just selected. Here those are its data, and for the correction factor we will change it from 1 to P0.7. This is, as we said before, because we are working on an outdoor project. Hence, the losses in the light will be larger due to the surrounding factors. So for that purpose, we change the correction factor to P only 0.7. So that's for the luminaire which we will use. Now let's access the second tab, which is the pool or POOM. Here at that tab, we will enter the data related to the pool itself. So for the POOM length, let's make it to P 0.4 meter or 40 centimeter. So let's make it here to P 0.4. This is, as we said before, the poom length ranges from 0.2 till 1 meter. So we suppose now we are having an arm or a poom that has a length of 0.4 meter. And then for the poom angle, we can set it to P 20 degree. So let's make it to P 20 degree. As the ideal angle ranges from 15 till 20 degree. So it will be a suitable value if we set it to P 20 degree. And also for the distance pulled to roadway, we can set it to P 0.5 meter. So we change it to P 0.5 meter. And then the important piece of data we enter is the mounting height. So we can set the mounting height of the luminaire to P 12 meters. And then for the number of luminaires per pool, we can set it to P 1 luminaire per pool as default, as each pool will have only one luminaire hanged on it. And after that, for the pool distance, which is the distance between each two pools, so it depends on the type of the street. Is it a fast street or a highway street, which is a street outside the city, or it's a limited speed street, which is a street inside the city. Hence, we can suppose that this is a limited speed street inside the city. Hence, the pool distance will equal a range starts from 3 till 4 times the pool height. But the pool height is 12 meters, so it will be suitable if we set the pool distance with 40 meters. Here we can change it to P 40 meters. And that's it. So that's about the important data in this tab related to the pool or the poom. Now we will jump to the third tab, which is the arrangement. And at that arrangement, we select the type of arrangement. Is it a single side arrangement or a double side arrangement with an opposing arrangement, or it's a double side with an offset? So if you remember, this depends on the street width, but our street width is 12 meters. Hence, we set it to be a double side arrangement according to our street width, as when the street width starts from 12 meters, so our arrangement will be a double side arrangement. So let's select a double side opposing arrangement. Very good. After finishing, we will press on insert to insert the lighting poles and the luminaires to our street. Alright, you can see those are the luminaires which we have, and this is our street. Here this is a luminaire, this is an opposing one, and this is a luminaire, and this is another one, and so on. Now, the final thing we need is to check if this is a right design or a wrong design. And to do so, we will access the single sheet output of this street design, which has the summary of this street. And to access those results, we need to go to the output tab. So we will press on output, and then we select the street which we are working on. So we access project 1, and then we select street 1 as we are working on a street 1. And after that, we open the valuation fields, and then valuation fields for road 1, and then we check the results overview as we need to check the results. And here we press a double click on it, and now it asks us if we need to start calculations. So we need to start calculations to calculate the required likes for this street or the value which we have got. And now we press on OK. Alright, now we press another double click on the summary overview, and that's it. Here this is the sheet which has the results of our street, and the only important thing we need to check now is U-note if it's larger than 0.4, as if U-note is larger than 0.4, this will be an accepted design, and if it's smaller than 0.4, this will be a wrong design. So it's obvious now that our U-note value is 0.71, which is larger than 0.4, so it's an accepted value, and our design is an accepted design. Alright, and by that way we have designed a correct straight design with the correct required parameters. And now we can see our design in the 3D modeling, so we press on the 3D view. Here this is our straight, we can zoom in a little bit. So this is the pool distance, which is the distance between each pool and the other. From this pool, for example, to this pool, it's 40 meters. And we have two opposing luminaires and two opposing luminaires. And also the street width is 12 meters. And here, if we zoom in a little bit, you can see here. This is the arm of the pole, and this is the luminaire which we have used. So the arm length or the boom length is 0.4 meters, and for the boom angle it's 20 degrees as what we have selected. Very good. So that's about this tutorial at which we completed the street lighting design. Hope that's clear right now. Thank you for watching and see you next tutorials.